Welcome to my lesson on atomic structure and the periodic table. In this lesson, we are going to answer questions on the mentioned subtopic, atomic structure and the periodic table. And the main topic is definitely atoms, elements, and compounds. It's very important that we discuss this topic because it is actually the major foundation of chemistry. So, to start with, I would like to introduce to you this topic, atoms, elements, and compounds. When we look at atoms, we understand that atoms are the building block of elements. Meaning, in elements, we are going to find atoms. That's the reason why we define an atom as the smallest particle of an element that can take part in the chemical reaction. Now, since these atoms can take part in the chemical reactions, we can also discuss the compounds, because when they take part in the chemical reactions, what are formed are compounds. That's the reason why we are saying the topic is atoms, elements, and compounds. Now, we see the value of an atom. The atoms also have three fundamental particles or subatomic entities, also known as subatomic particles. Each atom is going to contain electrons, protons, and neutrons. These are the building blocks of every atom. Where are these subatomic particles located in an atom? You will find the protons and the neutrons in the nucleus of an atom, while electrons orbits around the nucleus. That's very important. Another reminder will be on the charges of the subatomic particles. You will find that electrons are negatively charged, protons are positively charged, neutrons have no charge, the charge is 0. Therefore, we are going to say, since the charge of neutrons is 0 and the charge of protons is positive, we are going to say the charge of the nucleus is positive. And the charge of energy levels, since in the energy levels we have electrons which are negatively charged, the charge of the energy levels definitely will be negative. Therefore, there will be that electrostatic force of attraction between the energy levels, electrons, and the positively charged nucleus where we have the protons. That causes electrons to be moving around the nucleus. Because of that electrostatic force of attraction between the nucleus and the electrons. For this to be possible, we understand that it is very important for the number of protons to be equal to the number of electrons in the neutral atom. By that I mean, in a neutral atom, the number of protons are equal to the number of electrons in the neutral atom. Now, this is just my introduction, but the main concern is for us to be able to answer questions on atomic structure and the periodic table. And we're mentioning the periodic table because these atoms are presented according to their increase in atomic number on the periodic table. Without wasting a lot of time, we are going to go straight to the questions. We see how questions come. Definitely, I welcome both learners who start or take Cambridge, which is IGCSE, definitely that is 0620, as well as my learners who are doing ECZ syllabus to take part in this lesson, because this is going to lay a good foundation in chemistry. So don't say, no, this is just for Cambridge. No, even ECZ, make sure that you follow this lesson. So go straight to the questions. Question number 1. The table gives the composition of 3 particles. We have 3 particles, the same particles we mentioned, and these are protons, electrons, and neutrons. And we have particles A, particles B, particles C. A is having 15 protons, B 15, C 15 protons, electrons 15, 15, 15, neutrons 16, 16, 17. What is the evidence in the table for each of the following? Particle A is an atom. What evidence is there on the table? The evidence is here. I said, in a neutral atom, the number of protons are equal to the number of electrons. If the number of electrons are equal to the number of protons, and that particle is going to qualify to be called an atom, because an atom is neutral. So we are going to say the evidence is it has the same number of protons. This is the correct answer, my dear learners. You will get your 1 mark without fail. We go to question A2. A, B, and C are all particles of the same element, which evidence is showing that A, B, and C are the particles of the same element. When we come back to the table, we find that all particles are having the same number of protons. If particles are having the same number of protons, just know that all particles are of the same element. So since we have 15, 15, all of them are having 15, then we are going to conclude that the particle is of the same element. Without even wasting time, we are going to say the evidence is that they all have the same proton number. That is the evidence enough. Here you are going to get your 1 mark without doubting. And then we continue, we go to 1.3. Particles A and C are isotopes of the same element. The key word, my dear learners, here is isotopes. We understand for elements to be isotopes of each other, they are supposed to have different neutron number but same proton number. So when we go to the table, we are going to look for the subatomic particles that are having same number of protons but different neutron number. So when we look at A and C, A is having 16 neutrons, C is having 17 neutrons, but the number of protons are just the same. That is an evidence enough that these particles are of the same isotope. So we are going to write. We are going to say they both have the same proton number, but different neutron number. That's a fact. That is an isotope. It's supposed to have the same number of protons but different number of neutrons. What is the electronic structure of particle A? When we look at particle A, we'll find that the proton number of this particle is 15. As we confirm, we have it here. So the particle A is having the proton number 15. So when we go back, we can now answer the question. The question is saying, what is the electronic structure? Now, when we say electronic structure, what do we mean? Electronic structure is more like electronic configuration. So here we are talking about electrons, the distribution of electrons in shell, but we are going to represent that distribution in form of numbers. How many electrons will be there in the outermost shell? If at all we have 15 as the atomic number. So we are going to say first shell will have 2, second shell is going to have 8, the last shell is going to have 5. This is our electronic structure of a particle A. You are going to get, here you are going to get your 2 marks, where we are going to say same number of protons, different number of neutrons. Here you are going to get your 1 mark, because you have presented your electronic structure of particle A very well. Okay. Is element A a metal or a non-metal? Give a reason for your answer. My dear learners, you need to understand that an element qualifies to be a metal if it is having the number of electrons less than 4 in the outermost shell. If it is having 1 electron in the outermost shell, 2 or 3, that element qualifies to be a metal. Except for hydrogen, boron, and helium. Those elements have less number of electrons in the outermost shell, but they are still non-metals. So there are exceptions which you need to understand. So in this case, when we go back to B1, you will find that the number of electrons in the outermost shell of particle A is above 3, meaning this substance must be a non-metal. Therefore, we are going to say it is a non-metal, comma, because it has 5 valence electrons, hence react by gaining electrons. Non-metals react by gaining electrons. Metals react by losing electrons. It is easier for metals to lose 1 electron than gaining 7 more electrons as for that atom to be stable. That's the reason why metals so that electrons so that they can become stable. Non-metals gain electrons so that they can become stable. Moving forward. We go to question 2. Protons, neutrons, and electrons are subatomic particles. Complete the table to show the relative mass, relative charge of proton, neutron, and an electron. Here we are talking about 1 proton, 1 neutron, and 1 electron, as we can see in the question. So what is the charge of a proton? The charge of the proton, in my introduction, I said the charge is positive. The mass is 1. Neutron, the mass is 1. The charge is 0. Electrons, the relative mass is 1 over 1840. The relative charge is negative. You are going to have your 3 marks like that. We go to 2b. Bromine has 2 isotopes. Define the term isotope. Atoms, beg your pardon, atoms of the same element with same proton number but different mass number. Mass number or neutron number. What is an isotope? When we look at iso, this suffix means something must be the same. So here what is the same are the proton numbers but different mass numbers. Explain why the 2 isotopes of bromine have the same chemical property. The reason is very simple. When substances or chemical substances are having same number of protons, definitely they will have the same number, they will have the same chemical properties. Reason being that in the outermost shell of those particles, they will have the same number of electrons. If they will be found to be non-metals, it means they will be reacting by gaining equal number of electrons. If they are metals, they are going to be reacting by losing equal number of electrons. Therefore, they are going to have the same oxidation state. And that's the chemical property. Therefore, we are going to say bromine will have the same chemical properties because they both have equal number of protons. That is very, very important. Very, very important. You are going to get your 2 marks without even doubting, because that's the truth. moving forward, the table shows the number of protons, neutrons, and electrons in some atoms or ions. Very important, my dear learners, for us to understand atoms. When we say atoms, an atom is not charged, an ion is charged. So when we look at our table, the examiners are demanding us to complete the table. We have the pair of particles, we have lithium, and we have sulfide. Now, lithium is having a superscript 7 and it is having 3 as a subscript. Sulfide is having 34 and then it is having 16 as a subscript. And then we say we complete the table. Number of protons. The number of protons will be 3 for lithium because the proton number is 3. So that is straightforward. Now, lithium is not charged, meaning even the number of electrons will be equal to the number of protons. So even here the answer will be 3. Number of neutrons, we subtract the proton number from the mass number. So the mass number is 7 minus 3, where the answer is going to be 4. So we have 4 there. For a sulfide, the number of protons does not change, it will be 16. The number of electrons will change because we are having this sulfide having the charge of 2 negative, indicating that this particle gained 2 electrons. So the number of electrons will increase from 16 plus 2 to 18. So we are going to say the number of electrons will be 18. When it comes to the neutron number, we are going to subtract 16 from 34. So 34 minus 16, the answer is going to be 18. That is very important, my dear learners. And then from here, we are going to say, okay, fine. Here they have given us 18 electrons, 22 neutrons, and 19 protons. What are we going to do? What are we going to do? We are going to say, okay, fine. Since the number of protons are different from the number of electrons, we are going to say 19 protons and 18 protons. It means we are decreasing the number of electrons because we said in a neutral atom the number of protons should be equal to the number of electrons. Now, since in this case the number of protons are not equal to the number of electrons, it means this particle is not neutral. This particle is charged by losing 1 electron. Now, after losing 1 electron, we expect this particle to have a positive charge because that indicates that it's a metal. Now, using our periodic table, looking for the particle with the proton number of 19, we'll find that this particle is going to be potassium. Potassium lost 1 electron, indicating that it was positively charged. The number of protons will never change, it will remain 19. As for us to find the nucleon number, we add the proton number with the neutron number, and our answer is going to be 41. Looking closely on the periodic table, we are not going to observe that potassium is going to have the mass number of 41. It will have the mass number of 39. But in this case, what was used was an isotope of potassium 39. So this is correct. We are not going to say we have failed, no. So what was used here was an isotope of potassium 39. That is very, very important, my dear learners. So we are going to get our 5 marks just like that. Moving forward. Define the term atomic number. When we are talking about atomic number, my dear learners, we are definitely talking about the proton number, the number of protons in the nucleus of an atom. So this must be very simple for you. So we are saying number of protons in the nucleus of an atom. Define the term nucleon number. Nucleon is coming from the word nucleus, so we are talking about the particles that are there in the nucleus. The particles that are there in the nucleus, we have protons and neutrons. So the total number of protons and neutrons will give us the nucleon number. So we are going to say the nucleon number is the total number of protons and neutrons in the nucleus of an atom. That is very, very important, my dear learners. You are going to get your 1 mark, you will get your 2 marks, because we are going to mention the total number of protons and neutrons. Okay. Moving forward. We go to B. The table shows the number of protons, neutrons, and electrons in some atoms or ions. Complete the table. The first line is given as an example. So we have the line of particles. We have the proton number, electrons, neutron, and the formula. So we'll go direct to B. Proton number 12, electron number 12, neutron number 12. When we go to the atomic, or should I say the periodic table, we look for a particle with a proton number of 12, we'll find that it will be magnesium. The proton number is 12, so a subscript will be 12. We add the number of protons with the number of neutrons, we'll find the nucleon number, which will be 24. We write it as a superscript, that is 24. We come to C. We are able to see that this is oxygen, which has gained 2 electrons. It is having 8 and 16. Now, the neutron number, we subtract the mass, the proton number from the mass number. Here it will be 8. Electrons will increase from 8 to 10 because we are going to add 2 more electrons, so it will be 10. The number of protons is actually given, so we have answered. We come to D. We are having the proton number 11. We go to the periodic table, we find that the particle which is going to have 11 protons will be sodium. So we understand that here we are going to have sodium. And then from there, the number of protons are not equal to the number of electrons. This indicates that this particle is charged. This particle lost one electron, so it will be a positive. When we add the number of neutrons and the number of protons, we will go to 24. Then the proton number is 11. So again, remember my dear learners that we have sodium 23 and sodium 24. So what was used is an isotope of sodium 23. So this is also correct. So you need to think critically as for you to be able to answer questions very well. So it means we have answered this question. You are going to get your 6 marks without doubting. We are moving very well. Let's see if we can answer one more question. Let us answer this question. The table below gives information about particles. Complete the table. The first line has been done for you. So this has been done for us. Now we'll go direct to what we have not been given. This must be very simple, my dear learners. What is important is just for you to have a very good concept. Looking at the row number B, we are having this particle charged negatively. When the particle is charged negatively, it means that particle gained one electron because it has the charge of 1. So initially it was having how many electrons? It was having 17 electrons. So in this case, to find the number of protons, we are going to subtract 1 from 18 so that we can have 17. Why are we going to have 17? Because the number of protons does not change. Only the number of electrons are able to change. That is very important. We go to C. C, we are having electrons not given. The charge is given. The electron configuration is also given. Now, since the charge is 0, it means this particle C is neutral. Meaning, since we have 18 protons, even the number of electrons will be 18. Because we understand the number of protons are equal to the number of electrons in the neutral atom. We come to D. D again, we can see that the number of protons are different from the number of electrons, as you can observe. We are having the number of electrons increasing from 8 to 10, meaning this particle gained 2 electrons, so it is going to have 2 negative. The number of electrons changed. The number of protons does not change. Now, electronic structure, when we say electronic structure or electronic configuration, we talk about the distribution of electrons in their energy levels. Since the number of electrons increased, it means even the number of electrons in the outermost shell will increase. So we are going to say the first shell is going to have 2, the second shell is going to have 8. When we add 2 plus 8, will go to 10. So this is our answer. You are going to have your 4 marks, as you can just count there. 1 mark, 1 mark, 1 mark, 1 mark. That's very important. Very, very important. Let us look at B. Gallium is a group 3 element. Define the term element. My dear learners, an element is a pure substance that cannot be split into two or more by any chemical means. Very important. We cannot split an element into two or more by any chemical means. Meaning, we understand that elements contains atoms. Those atoms are unsplittable. We can only transform the reagents from the reactant side to the product side. But we are going to maintain the same nature, the same type of elements in the chemical reaction. We cannot split to form, to divide them into two or more by any chemical. But physically it's possible, you can do that. But chemically it's not possible. Okay, moving forward. The following are gallium atoms. We have gallium 69 and gallium 71. Complete the following table. Number of protons here will be 31, even here 31, and then number of electrons. Since gallium is not charged, the number of protons are equal to the number of electrons. So 31, 31. We find the neutron number by subtracting the mass number with the proton number. So we are going to say 69 minus 31, and the answer is going to be 38. For this one, it will be 71 minus 31, which is going to be 40. So from here we even understand that these two atoms are isotopes of each other. That is very, very important. Very, very important. So the concept you need to understand is just a matter of knowing what happens, what changes. Electrons number changes, proton number will never change. Okay. We can do the last question. Question number 5. The symbols of 6 particles are shown below. Select from the list of particles to answer the following questions. A particle may be selected once, more than once, or not at all. Number 1. Which two ions have the same electronic structure? We try. We have sodium. Sodium is positive. The atomic number of sodium is 11, meaning the number of electrons in this case will remain 10 because 1 was donated since it is positive. So it is going to have 2, 8. When we look at calcium, the atomic number is 20. In this case, it had lost 2 electrons. So for calcium, 2 positive, the electronic structure will be 2,8,8 because it remained with 18 electrons. For oxygen, this is sodium, my dear learners, sodium with a positive 2,8, calcium 2,8,8. Oxygen gained 2 electrons, so from 8 we are going to have 10, so it is going to be 2,8. So as you can see, sodium and oxygen are having the same electronic structure. So here we are going to say the answer is sodium ion and oxide ion. Which ion has the same electronic structure as that of argon? Argon, the proton number of argon is 18, although I'm not having the periodic table, but I understand it's 18. So 18, when we say argon 18, meaning the first shell 2, second shell 8, we have 10 in total, we remain with 8 in the outermost shell, meaning this electronic configuration of argon is similar to that of calcium ion. So here we are going to say calcium 2 positive. Which atom can form an ion of the type X3 negative? This substance must be a nonmetal. And here we have 3 nonmetals. Actually, even krypton is a nonmetal, it's a noble gas. Now, this krypton cannot form ions because it is a stable element. So the answers will come from phosphorus, silicon, or oxide. But oxide is having 2 negative, which is different from X3 negative. So meaning this is out. So we have phosphorus and silicon. Now looking at silicon, the proton number of silicon is actually 15. So we are the proton number of phosphorus is actually 15. So we are going to say phosphorus 15. The first shell is going to have 2, second shell 8, the last shell will have 5. This substance, it means it reacts by gaining 3 electrons. So since it gains 3 electrons, it is going to form 3 negative. So the answer here is P. Which atom can form an hydride which has a formula of the type XH4? Okay, so we need to think. This 4, the 4 here is coming from X. Since the 4 is coming from X, we understand that the valence of this X should be 4. So we are going to look for the element which has 4 valence electrons. And the only qualifying answer here is silicon. Silicon has the valence electron of 4. So we are going to say silicon has the valence of 4, hydrogen has the valence of 1. When we crisscross here, we are going to have silicon H4, meaning this is silicon tetrahydride. So we are going to have silicon as the answer there. So very important, my dear learners, as for you to understand that. Make sure that you know what you are talking about, because without understanding the concepts, you'll be thinking maybe atomic structure is difficult. But this is very simple, just understand the concepts. So moving forward, We can now do B. How many protons, neutrons, and electrons are there in one copper 2 ion? So we can see that copper 2 ion is having 64 and 29 as a proton number. It is charged 2 positive. Now, the number of protons will not change, so it will be 29. The number of neutrons, we are going to say 64 minus 29. The answer, using a calculator there, we are going to say 64 minus 29. The answer will be 35. The number of electrons, as we can see, it is charged 2 positively, meaning it had lost how many electrons? 2. So we are going to say 29 minus 2 electrons. We are going to remain with 27 electrons. This is very, very simple, my dear learners. We can now look at two. The nuclide notation of scandium, which is SC45 and 21. 21 represents an atom of scandium, this nuclide notation. How many nucleons and how many charged particles? How many nucleons and how many charged particles are there in one atom of scandium? My dear learners, when we say nucleon, we are talking about the nucleus. So in the nucleus, we have the total number of protons and neutrons. And this number here gives us the total number. So here we are going to say 45. Number of charged particles. In the nucleus, we are going to have positive protons. So the number will be 21 in the nucleus as charged particles. Moving forward, the different atoms of sodium are, we have sodium 23 and sodium 24. Explain why these two atoms are isotopes. Because they have same number of protons but different number of neutron, or we say we can say neutron or mass number. We go to C2. Sodium 24 is radioactive. It changes into an atom of different element which has one more proton. Identify this element. So, since sodium is going to have the atomic number of 11, when we say 11 plus 1 will come to 12. Now, going to the periodic table, we'll find that the number of protons of magnesium is 12. So this one becomes magnesium. Okay, moving forward. State 2 uses of radioactive isotopes. We have a lot of uses of radioactive isotopes. One of the uses, number 1, for example, radium is used, should I say uranium? Uranium is used to make nuclear weapons. And atomic bombs. Another use, we have elements like cobalt. For example, cobalt is 60, which is used to treat cancer. Some radioactive isotopes are also used in gauging the thickness of paper and metal sheets. Very important. So this is where we are going to end. I just hope we have moved it together. Find time to go through. We are going to continue, but I think what I am going to do next, I'll answer some questions from 2019 Cambridge paper, mainly on atomic structure, so that we can see the paper and we see how the questions come in exam papers. For now, I say thank you. Enjoy the rest.